This is a demonstration for lab number 3. Actually, it's a continuation of lab number 2, where you use the mixing rule to find 3 properties: the specific gravity, the reduced pressure, and the reduced temperature. In this exercise, you are going to calculate other properties using templates and formulas. And one of them is a chart. So you need 5 variables, 5 parameters from lab number 2. You need 8. 5 of them have been transferred for you. That's the mole fraction for nitrogen, mole fraction for carbon dioxide, mole fraction for hydrogen sulfide, then the pressure and temperature of the gas. You need to transfer 3 more. Those are the ones you calculated yourself. You need the specific gravity, you need the reduced pressure, you need the reduced temperature. Okay, so the first thing we're going to do is to copy these 3 other parameters from lab number 2. So I'm going to open my lab number 2. I'm going to copy those 3. Those are the ones we calculated from lab number 2. So I'm going to copy, go back to my spreadsheet. Then I'm going to, now you don't just paste because you have formulas in those cells. So you have to paste only the value. So I'm going to open paste. I'm going to select the one that says paste value 1, 2, 3. Okay. Okay, paste value. So I have all the parameters I need for this lab. So let's go one by one. The first one says find the viscosity using the Kakobayashi template. So what do you need for that? I'm going to open the Kakobayashi template. Kakobayashi. So here's the template. What you need, this is the input. I need the pressure, that's 950. The temperature you have to provide it as in Fahrenheit. Okay, because you see F is there, so you have to write it in Fahrenheit. The gas specific gravity. So what you can do actually is, you can just do here, copy. Now go back to Kakobayashi. And I do paste value again. Okay. Then the mole fraction for nitrogen, carbon dioxide, and hydrogen sulfide. So I can just go back here again. I highlight all the 3. I do copy. I go back to my Kakobayashi. Then I do paste value. Okay. So once you have the 6 parameters, goes to the bottom, that's your viscosity. Remember also it's a formula. So when you copy, you come back to your spreadsheet. Here you have to paste value. Open, paste value. The next one is Brilbex. I'm going to go back to my Kakobayashi because it's the same parameters I need. So what I do is I just highlight all the parameters that I use for in Kakobayashi. I copy them. Then I open BreelBex. I can paste this because it's not formula, it's just number, so I can paste directly. So once you paste that, they are all the same parameters. So I go back, I go there, I see that's the compressibility factor. So I copy, that's the last number there. So I come back here. So I'm going to do paste value so that I don't paste the formula. So I got all those now. Now, for the chart, I already demonstrated that in your note. What you need is the reduced pressure and the reduced temperature. So I'm going to approximate this to 1.4 and this is 1.45. And I already demonstrated that. Check your note how I got the Z factor from that chart. So I think we got 0.85. So I'm going to put 0.85 there. Now, so yeah, the last 5 parameters you have to input formulas there. So this one, the first one is density, rho. For density, this is the formula for density. So I'm going to just follow the formula and type it in Excel. Now, you know, before you type a formula, you start with equals. So I'm going to put equals 2.7 multiply is shift 8, which is asterisk, multiplied by P is the pressure. I'm going to look for the pressure. I click on the pressure, then multiply again by gamma, which is the specific gravity. So I'm going to click on the specific gravity. Then I'm going to divide by 2 things. First of all, so divide is do slash Z. You have to use Z from BreelBex, that which is more accurate than from the chart. So I'm going to use this Z. Then divide again by temperature. So you do another slash. Because it's divide, so you have to keep doing slash. Don't do multiply. So I do slash what? The temperature. You have to use, in this case, when you are calculating, you have to use the Rankine. So I'm going to use this temperature. You don't use Fahrenheit in calculation. Although in the template, you use the Fahrenheit, but when you are doing your own calculation, you have to use Rankine. So that's all. So I'm going to do okay. So that's the density, pound mass per cubic feet. I've already even done this in the previous note. The next one is the formation volume factor, and that's the formula for that. So I'm going to do equals 0.0283. Don't forget the 0 before the 2. Some people used to forget that. So it's 0.0283 multiplied by Z. I'm going to click Z from BreelBex. Then multiply by temperature. The temperature, which is the Rankine. Then divided by the pressure. Slash pressure. So that's the B. B is usually less than 1, so it must be less than 1, much less than 1, because the volume in the reservoir is always less than the volume at the surface. Now, this is the expansion factor by what as its gas expanded when it gets to the surface. So that's the inverse of volume formation factor. So it's going to be equals 1 divided by slash. Then I click on the volume formation factor. So that's 69.77. So the gas has expanded by almost 70 times. Now, the last two, you have to use this formula. That's calculating the critical pressure and critical temperature from formulas. Remember, in lab 2, you use the mixing rule to calculate it. But here we're going to use formula to calculate the critical pressure and the critical temperature. So let's use the formula. Let's follow. Equals. We're doing the critical pressure first. You have 678 minus 50. Now see, you have a bracket open there. You can't just open the bracket. You have to first of all multiply star. If you don't put the multiplication sign, it will give you an error. So multiply them before you open the bracket. Now I'm going to open the bracket. I did something wrong there. Okay. I'm going to open the bracket now. 50 star open bracket, then gamma, which is the specific gravity, so I'm going to click on that, minus 0.5. Then I close the bracket now. Then minus 206.7 multiplied by Yn2 is the mole fraction of nitrogen. So multiply by star. Then I go to mole fraction of nitrogen, that's that. Then plus 440 multiplied by mole fraction of carbon dioxide. So star, mole fraction of carbon dioxide, that's that. Then plus 606.7 multiplied by mole fraction of star, mole fraction of hydrogen sulfide. That's that. So I say that's okay. So that gives me 682.24. Now let's do the temperature. The critical temperature equals 326 plus 315. Now I have to do multiplication before I open the bracket. Star, then I open the bracket. Gamma, which is the specific gravity, I click on that. Minus 0.5, minus 0.5. Then I close the bracket. Minus 240 multiplied by star, mole fraction of nitrogen. I click on that. Minus 83.3 multiplied by mole fraction of carbon dioxide. I click on that. Then plus 133.3 multiplied by mole fraction of hydrogen sulfide. That's it. So I just say okay. So that gives me 381.92. Now let's do something. You know, we use mixing rule to calculate the critical pressure and critical temperature in lab 2. So let's verify my lab 2. What was the value for lab 2? Lab 2, my critical pressure was 686.58. Now I got 682. It's very close. The critical temperature was 383.77. Now I got 381.92. So it's very close. So that means the mixing rule and the formula are very close. They are reliable. So whenever you finish with the lab, save it and upload it to Canvas. That's it.